Morning.
The first chapter of physics, is light, reflection, and refraction. Okay. So as per the syllabus, first we will complete what is reflection of light by curved surfaces, then all the image formations by spherical mirrors, then what is the center of curvature, principal axis, principal focus, focal length. Then we will do the mirror formula. Derivation is not there. Then magnification. Till here, we will complete it in our first video. So we start with reflection of light. Reflection of light. Okay. So you must have learned in the smaller grades about light reflection. Okay. So the chapter is light, reflection, and refraction. Light, reflection, and refraction. So the total chapter deals with the two phenomena of light, reflection and refraction. So in the first video, we will learn about reflection of light. So what is reflection? It is the bouncing back of light. When light falls on any opaque object, the light will bounce back. The bouncing back of light, we call it as reflection. For example, you take a cricket ball, you throw it to any wall. What will happen? The ball will not pierce and go to the next room. Instead, it will bounce back. Okay. So bouncing back of light, we call it as reflection. Normally reflection occurs in mirrors because one side of the mirror is always opaque. Mirrors are of two types in this chapter. First mirror is plain mirror. That means there is no curvature, okay? There is no curvature. It is plain mirror. And the second type of mirror, we call it as spherical mirrors. Spherical mirrors are mirrors which are cut out from a sphere. If there is a sphere, if you cut the sphere into two, you will get two types of mirrors. Okay. So if the reflecting part is curved outward, then that type of mirror, we call it as convex. And if the reflecting part is curved inward, that type of mirror, we call it as concave. So spherical mirrors are mirrors which are cut out from a sphere. Okay. Mirrors which are cut from a sphere, we call it as spherical mirrors. And spherical mirrors are mainly classified into convex mirror and concave mirror. Now let's see about the reflection of light in detail. Okay. So this is a opaque object. Okay. And I'm drawing a normal at the surface. And this is my incident ray. This is my incident ray. Okay. So at the point of incidence, I have drawn the normal. Now, at the normal, what is happening is at the point of incidence, the ray will reflect back to the same medium. And this is what we call it as reflected ray. So you can see that incident ray, reflected ray, and the normal, you can see it with your eyes. That means all are falling on the same plane. So what is the first law of reflection? There are total two laws of reflection. The first law is incident ray, reflected ray, and the normal. Where at the point of incidence. Normal at the point of incidence. At the point of incidence. All lie on same plane. All lie on same plane. This is the first law of reflection. Second law is, the angle which the incident ray makes with the normal, we call it as angle of incidence. And the reflected ray making with the normal, we call it as angle of reflection. So what is our second law is angle of incidence will be equal to angle of incidence will be always equal to angle of reflection. Angle of reflection. These are the two laws of reflection. So sometimes how the question asked is in the diagram, they will tell you that this angle is 30 degree. So what is angle of reflection? How you will calculate it, children? If this angle is 30, automatically this angle is 60. So as per the law, this will be also 60 degree. Okay. So this is how we manage the reflection type of angle sums. So reflection is the bouncing back of light, and there are two laws for reflection. Now we will study the mirrors in detail. Okay, we are going to learn about the spherical mirrors in details. Okay, so this is how I draw a concave mirror. Okay, concave mirror. The exact geometric center of the mirror, I will call it as pole. So what is the definition of pole, children? It is the exact geometric center of a mirror. Exact geometric center of a mirror. Center of a mirror, we call it as pole. We represent it by the letter capital P. Now, this mirror must have been cut out from some sphere. So let's see from which sphere it's being cut off. Okay. This mirror must have been cut out from some sphere. Okay. So we will complete that sphere, and the center of the sphere of which this mirror is a part, we call it as center of curvature. Center of curvature, we call it as C. What is center of curvature, children? It is the center of the sphere. It is the center of the sphere of which the mirror is a part of. The mirror is a part of. This is what we call it as center of curvature. We represent it with the letter C. Okay. So now this sphere will have a radius. The sphere will have a radius, and that we call it as radius of curvature. Radius of curvature, which is represented by capital R. So what will be radius of curvature, children? It is the radius of the sphere. It is the radius of the sphere of which the mirror is a part of which the mirror is a part of which the mirror is a part of. Okay. Now, coming to the imaginary line which passes through C and P, the imaginary line which passes through C and P. Actually, there is only one line which can pass through 2 points. So, we have only one principal axis for any mirror, and that we call it as principal axis. So, what is principal axis, children? It is the imaginary line. It is the imaginary line passing through C and P, passing through center of curvature, and pole. Every mirror will have only one principal axis. Now, any parallel ray to the principal axis after reflection will pass through a single point on the principal axis. And that point, we call it as focus, represented by capital F. So, all parallel rays after what? Parallel rays to principal axis. Parallel rays to principal axis after reflection will pass through a single point. Okay. After reflection will pass through a single point. will pass through a single point called focus. Single point called focus, represented by capital F. And the last one is distance of focus from pole. We call it as focal length, represented by small f. So what is focal length? It is the distance of, focus from pole. Focus from the pole. We call it as focal length. So the first relation in the chapter, what we need to learn is your radius of curvature is 2 times the focal length. Your radius of curvature will be twice the focal length. That means the focus will be always between the midpoint of C and P. And the average diameter of the spherical mirror, we call it as aperture. Aperture. It gives the average diameter of the mirror. So these are the major terms of a mirror. And what is the first relation? R is equal to 2F. Now we will see the major rays in a mirror. What are the major rays? Actually, there are 4 major rays. The rays are very easy. You know, there are 2 types of mirror. So both we will do it together. First major ray for concave, you put the opaque side here, then it is concave, and this is your convex. This will give your convex. Okay, the first ray. So first we will mark the pole and the focus. Pole, pole. Focus, double will be C. Focus, double will be C. So what is the first ray is, if the ray is parallel to the principal axis, it will pass through focus. If it is a convex mirror, if it is parallel, it will appear to diverge from focus. This is the first ray. Parallel, focus. Parallel, it will go through focus. It will diverge from focus. So what type of a mirror is this? This is a converging mirror. And convex mirror is diverging. Convex mirror is diverging. So this is the first ray. What is the first ray? Parallel ray after reflection will go through focus. Now let's see the second ray. Okay. Second ray is any ray which is falling through the focus. If the ray is falling through the focus, okay, if it is falling through the focus after reflection, how it will go, children? It will go parallel. So this is the reverse of the first one. Okay. Now same way, if the ray is falling through the focus, virtual focus for convex, so it will go parallel after reflection. Okay. So first ray is, if it is falling parallel, it will go through focus. But if it is falling through focus, after reflection, it will go parallel. Now let's see the next ray. Okay. What is the third ray is? The third ray is, if a ray is falling through C. If a ray is falling through C. Okay. If the ray is falling through C, it will retrace the same path. So through C, it will be retraced through the same. See, if the ray is falling through C, it will retrace. Always remember, children, after a convex mirror, don't draw straight line, because focus is virtual, center of curvature is also virtual. So 3 rays are over now. Parallel focus, focus parallel, and through C, through C. Now the last ray is any ray which is falling at an angle I. Any ray which is making an angle I. Falling at an angle I, it will retrace with obeying the law of reflection. That means fourth ray is angle I will be equal to angle R. So if it is falling at any angle with the same angle, it will reflect back. Okay. So these are the four major rays in mirror. What are they, children? Parallel, focus. Focus, parallel. C. Angle of incidence, angle of reflection. Now with these four rays, we are going to draw the image formation. The first one is for concave mirror. Concave mirror. Okay. So what is a concave mirror, children? The reflecting part is curved inward. The reflecting part is curved inward. So I draw the principal axis. Okay. This is my concave mirror. I draw the opaque part. Okay. Now I will mark all the parts of the mirror which we have learned. What are the parts? Pole. Okay. We have the pole. 2 centimeter, you draw your focus, and 4 centimeter, you will draw your C. You can take any measurement. 3 is also possible. 2 is also possible. Now, which are the possible position of the object we will see? You can keep the object, okay? You can keep the object at infinity. You can keep the object beyond C. You can keep the object at C. You can keep the object between C and F. You can keep the object at F, and you can keep the object between F and P. So remember, children, these are the 6 locations of your object. Infinity, beyond C, at C, between C and F, at F, and between F and P. So total, how many image formations are there for our concave mirror? 6. What are the object position? Object can be kept at infinity. Okay. Object can be kept beyond C. Beyond C. Third one, object can be kept at C. Fourth one, it can be kept between C and F. Just bring it towards the mirror, okay? No need to by heart. Then fifth one, at F. And the last image formation is between F and P. These are the 6 image formations of a concave mirror. Okay. And we know about the image, the different types of rays. Okay. So first 2 rays, first 2 you will take for first 4. Okay. Remember, children, for all the first 4 image formation, which rays you will take? 1 and 2. And for 5th and 6th, you will take the rays 3 and 4. Total 4 major rays are there. Always focus on first 4 image formation. You will take only 1 and 2. Okay. Now, the expected image position. If it is at infinity, you will get at focus. If it is beyond C, you will get it between F and C and F. And at C, you will get at C itself. Now, but we will check all these image formation once again after drawing. Now, at C. Now, reverse all these. You got the image at between F and C when you kept it beyond C. So, if you keep it between C and F, you will get it beyond C. Same way, you got it at focus when you kept it infinity. So, if you keep it at F, you will get it at infinity. And this is the only one where you will get a virtual image at the back side of the mirror. So these are the 6 image formations. Okay. Now we will draw all the image formations by following these 4 major rays. Starting with, what is our first object position, children? First object position is object at infinity. Object at infinity. You all know that the object at infinity means the rays coming from the infinity are all parallel. Okay. So I draw the mirror, pole, F and C. What are the rays, children? rays coming from infinity are all parallel rays. Parallel rays after reflection will go through the focus. Now tell me, children, what is the image? You know, an image is called as real image. Okay. If it meets after reflection. After reflection, if it is meeting, it will be a real image. And all real images are inverted. So what all we can talk about? Object at infinity, children. See, they are meeting. So what type of image it is? It's a real image. Now, real image is always inverted. And here, all are focused to F. So what type of image it is? It is point-sized image. Okay. Where is it formed, children? At F. These are the things you will be knowing regarding the characteristics of image when an object is placed at infinity. What are they, children? It's a real image. It's an inverted image. It is point-sized. And the object is, so the image is formed at focus. Okay. Now we will see about the second type of image. That means, what is the second position, children? Object beyond C. Object beyond C. Okay. So principal axis, mirror, mark all the points P, focus, and C. You take the object beyond C. So what are the major rays, children? Parallel ray. We have told to take the first two rays. Parallel through focus. What is the second ray? Through focus, it goes parallel. It goes parallel. Did they meet after reflection, children? Yes, of course. They met after reflection. And you can see that the image is formed between C and F. Since it met after reflection, it's a real image. Real images are all inverted image. Now, what about the size? Size is not as big as the object. So we can say that it is a diminished image. And where did we get it, children? Between C and F. Okay. So these are the first two image formations. Both of them, you got it as real inverted image. Now, what is the third position of the object is object at C. Object at C. Okay. So for object at C, first we will draw the principal axis, mirror, pole, focus, center of curvature, and this is the object position. Where? At C. The parallel ray after reflection will go through focus. Okay. The second ray through F. Through F. It will go parallel. Okay. So basically, it depends upon the measurement. If the measurements are proper, okay, if the measurements are proper, you will get it exactly at C. So let's see. So if it is the parallel ray, after reflection, it will go through focus. Okay. And if it is a ray which is falling through focus, it will go parallel. So you will see that almost you will get it at the same C. So is it meeting after reflection, children? Of course. So it is a real image. Real images are inverted. Okay. And this image, you will get it as same size. And where is the image, children? At C. Now, the fourth image formation is when the object is at object between F and C. Object between object between C and F. Okay. So how you will draw the, first we will draw the principal axis. Then we will draw the mirror, concave mirror, mark all the points, P, 2 centimeter or 3 centimeter your F, again 2 or 3 centimeter your C, and then you keep the object between C and F. What are the rays, children? Parallel rays after reflection. Parallel rays after reflection will go through C. And the ray which is falling through F, it will go parallel. So you will see that the image will be formed beyond C. Image is beyond C. Okay. So what are the characteristic, children? It's a real image. Real images are inverted. It is formed, or this is magnified, little magnified, enlarged. Okay. Magnified means enlarged, because it is bigger than the object. And where did you get it, children? Beyond C. So these are the 4 image formations where we are taking the rays parallel, focus, focus, parallel. Okay. Now the last 2 image formations of concave mirror are when the object is at F. Object at F. And 6th one is object between F and P. Okay. So let's see. We are taking the last 2 rays for the same. Okay. So this is our concave mirror. We mark the pole and focus and see pole, focus and see. Okay. And I keep the object at F. At F. Okay. What are the rays taken, children? We will take the first one is through C. Through C, you touch the tip and to the mirror. Through C, it will retrace. Okay. It will go back. Now, the second ray is if it is making an angle I. Okay. Definitely, it will take the same angle and it will reflect. And you will see that these are parallel rays. And parallel rays meet at infinity. Meet at infinity. So remember, children, they are meeting. So what type of image it is? Real image. Real images are inverted. And since it is meeting at infinity, it will be highly enlarged. Highly enlarged. And where is it formed, children? It's formed at infinity. Okay. The same rays we will see for between C and F. See, between C and F. What is the first ray, children? The one which is through C. How do we draw that? Parallel ray. I mean, the ray which is passing through C will touch the tip and it will retrace back. C. And what is the second one? The ray which is falling. Oh, we kept it at C. Wait a minute. It is between F and P. Sorry, at F and P. F and P. So this is the object. First ray through C from the tip. Okay. It is retraced back. And what is the second ray? Second ray is falling at P. Okay. So these 2 rays are diverging rays. So it's not going to meet anywhere. So we need to make it meet. When we make it meet, you will see that you get an image at the back of the mirror. Okay. And since it is not meeting really, it's a virtual image. Virtual image, you should draw it in dotted line. So what are the peculiarities of the mirror images? It's a virtual image. Virtual images are always erect. And it is an enlarged image. you get two enlarged images in concave mirror. Okay. But one is real and one is virtual. And where is it obtained, children? Back of the mirror. So these are the 6 image formations of concave mirror. So concave mirror, you must have seen that, in a concave mirror, you will get both the types of image. That is, you will get real and virtual. You will get diminished and enlarged. You will get direct and inverted. So all types of image formations are possible in concave mirror. Same size, diminished, enlarged, point size, highly enlarged. So concave mirror has all type of image formations. But when we come to convex mirror, you will never get a real image in convex. Okay. For example, the first image formation, this is the convex mirror. Okay. This is the pole. This is the focus and parallel rays. Okay. All parallel rays. What will happen, children? This is a convex mirror. So everybody will appear to diverge from focus. Everybody will appear to diverge from focus. This is the first image formation. Okay. So you get a virtual image. Virtual images are erect, point sized, at F. This is the first image formation in convex mirror. Moving to the second image formation, that is, this is most asked by the CBSE. So this is most asked by CBSE. This is pole, this is the focus, and this is your C. Okay. You keep the object anywhere in front of the convex mirror. What is the parallel ray, children? Parallel ray will appear to diverge from focus. The second ray is the ray which is passing through C. So till C, after that it is dotted line. Now you see, you get a virtual image because it is not actually meeting. Okay. So what is the nature of the image is, it's a virtual image. You will never get an enlarged image. Always it will be between P and F. Okay. So virtual images are erect and you can see that it is always diminished. Diminished. Okay. And then it will be formed always between P and F. So remember, children, if it is a convex mirror can never give you real image. And convex mirror will never give you an inverted image also. Always it will give you erect. So since it is always giving erect and diminished image, it is always used in automobile rear view mirror. Because rear view mirror, because you get wide field view. Wide field view. You can see many things at the back of the mirror. Okay. And then you will always get erect image. Okay. When you look while driving, if there is only one object or one image seen on the mirror, it will be difficult for us. Okay. So, and you will get always the erect images. So this is the reason why convex mirrors are always used in a automobile rear view mirror. Now in reflection, the only part which is left is mirror formula. Mirror formula. Okay. There are 3 different terms. U stands for object distance. That means distance of object from the pole. V stands for image distance. Image distance. That is distance of image from pole. And F, as we all know, it is the focal length. So there is a relation connecting all of them. We call it as mirror formula 1 by V plus 1 by U will give you 1 by F. Now we should learn the conventions also. But before that, there is one more term we can find in the mirror. That is, we call it as magnification. Magnification means how big the size of the image is. So magnification is HI divided by HO. And we get this as minus V by U. Okay. So basically, if magnification is equal to 1, what does that mean, children? HI will be equal to HO. That is same size. If magnification is greater than 1, HI is greater than HO. That is, it is an enlarged image. And when magnification is less than 1, your HI is less than HO. That means it is a diminished image. So these are the things which we can understand from magnification. Okay. Now the next is, if magnification is positive, if it is positive means HI is positive, because HO can never be negative. So what type of an image it is? When HI, when height of the image is positive, that means it is erect. So if it is erect, it will be a virtual image. So if the magnification is positive, it means it is a virtual image. So if magnification is negative, means your HI will be negative. HI is negative means it is inverted. So you get a real image. So these are the things which we will understand from magnification of a mirror. By seeing the magnification, you can understand that what type of an image it is. For example, if I'm getting magnification is equal to minus 3, what does it mean? Minus means you get a real image. It is 3. 3 means the value is 3. That means it is an enlarged image because 3 is greater than 1. Understood? This minus sign, always remember children, negative sign gives the nature of the image, not the value, okay? And this gives whether it is enlarged or diminished. So suppose if we take the Cartesian sign, this is your mirror, okay? This is the mirror. All the measurements to the left of the mirror are negative, right of the mirror are positive. Top to the mirror are positive, bottom to the mirror are negative. This is the major sign conventions. Okay, so for concave and convex, we can take like, what are the terms we have? You have U, V, F, HO, HI. Okay, first we will see what is always negative is V, irrespective of mirror, and which is always positive is HO. Okay. Now, regarding the focal length, if it is concave, it is negative, and convex, it is positive. Now, your V value. V can be positive and V can be negative. V is positive only in one case. We have seen all the image formation. Only for virtual image, the V was positive. And V is negative for real image because everybody was formed to the left side. Same way here also, if HI is positive, positive means it will be virtual and negative means it will be real. Okay. And about convex, your V will be always positive. Your HI will be always positive. So remember children, if it is a convex mirror, except U, all are positive. So with this, we can do maximum number of numericals. So what is mirror formula? 1 by V plus 1 by U equal to 1 by F.